No guarantees.
I can always try.
Yeah, but it looks good.
It is connecting. Perfect. We are live. And so many people are sharing the video. Thank you so much. So I will start with the presentation. I'll try to make it short, I promise. Share screen. Screen one, yes, perfect. And share. Can everybody see the screen?
Yeah,
I can see.
Perfect. So welcome everybody to this July .NET User Group Zurich session. Today is about async and await, some insights and pitfalls. Let's see the amazing animation of our user group, .NET User Group of Zurich. We have been there for a while, and hopefully we will still be there for some more. First of all, special thanks to Offering Solutions, Big Wow for Texture, and our usual, maybe not anymore, but we still love them, Impact Hub Zurich and the Stanford Group. They used to host us, and some partners like Azure User Group, .NET Central, .NET Day, Switzerland, and Swiss Angular. Thank you so much. But who is .NET Zurich? Well, it's a user group, and behind it, it's me, it's Powell, it's Michael. Say hi, Michael.
Hi.
It's Nigel. Today is not here. That's strange. Should ping him. Usually he comes to all the sessions. It's Laurent, Fabian, and Mark Muller. Amazing people. Most of them, or a lot of them, are MVPs or work for Microsoft. What do we do? Well, you know that. We organize events from developers to developers to share knowledge, get you excited, usually with some networking at the end. So we usually finish a stream, we close the stream, no more recording, and then we have a informal chit chat with all the people that decide to stay. And then whenever we could, back in 2019, we did and had beer and pizza. We still can do that from home, but yeah, not the same. But what can you do? You can follow us on Twitter, follow .NET Zurich, follow us in LinkedIn. We announce our sessions there, and we can be contacted there as well. You can join our meetup group. Well, you need to if you want the link, sorry. And you can tell your peers, help us grow, be members, that would be good. Propose content and speakers. If you have, for example, a talk of 15 minutes and you would like to deliver it, just pick me, pick Michael, pick anybody from the list that you just saw. And we have a website, .NET Zurich. And that's basically, today is everything about async and await, some insights and pitfalls, basically best practices, what to do and what not to do. And the speaker today is Stephen. He's a software engineer with a lot of passion. He comes from Germany. And what can I tell from him as well? He's also from a company, amazing service company, which is Zühlke. I know, I was there and I was working with Stephen, not in the same project, but we were having a group together, the .NET Be Next internal user group of the company. And well, it was pretty fun to be there with you, Stephen. And
thank you.
He's amazingly fun as a speaker, very agile. And I'm now going to put a challenge to all of you guys. He told me that he loves the questions as they come. He likes them hot. So feel free to shoot at him. And that includes you, Michael. But
Sure.
yes, you can be evil with him. And I mean that in a good way. So I look forward. I have been in some sessions with him, and he's quite an amazing speaker, apart from amazing professional, and it's going to be a fun session. So, Stephen, the stage is yours.
Thank you very much. I will take over the screen now that you set the bar quite high. Let's begin. Yeah, thank you Jose, for the introduction. As you also said, if you have any questions, just shoot. Whatever you want, whenever you want, it's totally fine. The topic, as we saw, is a bit of async await, some pitfalls, some general guidelines, how does it work, and yeah, what can you do better? Also, to introduce me, I'm a software engineer here in Zurich, working for Zühlke, originally coming from Germany. I love Blazor, for example. It's just the best, even though this slide, this presentation you see is mainly written in JavaScript. It's still, Blazor is just awesome. I love the .NET User Group. I like the concept. I love sharing knowledge, and the idea is just great. So let's have a small disclaimer why I'm doing this. The nature of async await, and especially the state machine, it can get quite complex. So in some aspects, I will simplify or even oversimplify. And I assume we all have some prior knowledge of async await. So I don't start from the very beginning. So I'll take this information with a grain of salt. What to come? First, let's have a small talk. What is asynchronous programming? What is parallel programming? What's the difference? Then let's have a short look at deadlocks, and especially what is this weird ConfigureAwait doing we all put in our libraries at the end of an await. Then we can briefly have a look at the state machine, really oversimplified, not how it works in real life, just the concept behind it, so you understand better what is going on internally. And afterwards, I will show you basically with Visual Studio or Writer some pitfalls and general tips. And then we have very, very brief outlook into the ValueTask. This was introduced with .NET Core 2.0. And the central question is here, should I use it or shouldn't I? And before we begin, before I go to asynchronous programming or parallel programming, I have a small thought experiment for you. And I will post a link in Zoom. You can go and there's a poll. Basically, there's this snippet as a picture and a poll. And what I want to know from you is how long or what is the runtime of those snippets? You have snippet A and snippet B. So I will try to share the link. I hope this is quite easy because my window of Zoom is just gone. I guess I can just open it here, can I? Here, chat, perfect. So I will send you the links. I hope everyone will see them. The first one is exactly that code snippet. And the second one is the link to the poll. Take it whenever you want. I will come back to this, let's say in 40 or 50 minutes. If you have time, you can have a brief look. Good. Then let's come to the first topic, asynchronous programming versus parallel programming. And what's the difference? Just imagine you want to cook some breakfast. How would you do that? It's pretty easy, isn't it? You pour a cup of coffee, you heat up some pan, and fry some eggs, then you fry some slices of bacon, then you put your toast in the toaster, add some butter, you get it all. So how would you do it in a synchronous way? Well, you would do everything after another. So first you pour the coffee, you wait until it's done, then you heat the pan, you wait until it's done, and then you fry the eggs. When the eggs are done, you put them aside and fry the bacon, and so on and so on. But if you have some experience with cooking, you would execute those instructions asynchronously. So you would start warming the pan for the eggs, then start the bacon. It's like you can do this side by side. You would put the bread in the toaster, and then basically you have 3 tasks aside, so asynchronously started. So at each step of the process, you would start a task and then turn your attention to the task that's ready for your attention. And cooking breakfast is a very good example of asynchronous work, which is in parallel. One person or thread can handle all these tasks. One person can make breakfast asynchronously by starting the next task before the first completes. The cooking progresses whether or not someone is watching it. As soon as you start warming the pan with the eggs, you begin frying the bacon. Once the bacon starts, you can put the bread into the toaster. If you would do this in parallel, you would need multiple cooks or threads. One would make the eggs, one the bacon, and so on. Each one would be focused on just that one single task. Each cook would be blocked synchronously waiting for his task to finish. That is the main difference. So let's bring some definition to that. What is asynchronously, what is concurrency, and what is parallelism? Let's start with concurrency. Concurrency is when two or more tasks can start, run, and complete in overlapping time periods, which doesn't necessarily mean they have to be parallel, so they don't have to run at the same instant. Parallelism is exactly what you would expect from a PC. When you have a multi-core processor, you have multiple tasks run literally at the same time. So on, for example, CPU 0, you have a task, and CPU 1, you have a task, and they run literally parallel. Now, what is asynchronous? Asynchronous is just a mechanism to achieve concurrency, but it's not the same. For example, in C# and in JavaScript, you do this via callbacks. And it doesn't necessarily involve multiple threads. And the best example is literally JavaScript, which runs only on one UI thread and still has async await. So one main point, which is really, really important here, you don't always have multiple threads involved. This is some key point you have to take always with you. And you have to be always aware that not only because you just wrote async and await, it doesn't mean you have multiple threads running in the background. That's not always the case, but we will look into that a little bit later. Now, let's go to the second topic, deadlocks and ConfigureAwait. How can I run into deadlock, and what does ConfigureAwait do? Just imagine the following ASP.NET snippet. This is the old .NET framework. This also would apply, for example, to WinForms or WPF. So it's just more of a general thing. And just imagine you have this function. This is to get something. This is from your controller, which gets called. And this is completely synchronous. And you start calling the do work async, which has some asynchronous call inside. For purposes here, we just take a task delay. So what really happens here if our controller reaches that? Yeah, well, first, we have the task. So we enter do work async synchronously because we are in a synchronous context. All work until the await will be done synchronously. So this debug write line, and also to this point, to line 11, we will be synchronously. The rest of this method will be returned as continuation task, and we return to the caller. We are back basically on the get something method. Here we go further to the task wait. So what does task wait do? Well, it basically blocks your thread until the await is finished or until your task is finished. So, okay, we wait here, that's fine. And we on line 11 have this delay for 500 milliseconds. And now this delay is done. What happens now? Yeah, we run into a deadlock. The point here is you have a context, the context locks itself. So you are waiting synchronously, so you're blocking your thread, but the task delay wants to come back, but it can't come back because it's blocked. It's not free. It can't go into this code anymore. It can't continue the continuation task because you're still waiting. So you run into a deadlock code or into a deadlock situation. So let's see this in action with ASP.NET. But as I said before, this also applies to WinForms or WPF and even to some testing frameworks like NUnit. Why is that? I will show you later, but let's first head to the console. And I prepared something here. This is basically our controller we had before. Was it this one? This one. So this is the same code as we saw before. We have the get method. The get method does something with do work async. We have here the delay and we wait here. And let's just go to the debugging point and look what happens. I can't debug as this bar of not WebEx. How can I remove the bar? Does someone know? Ah, I can just put it away. That's super nice. Okay, so let's debug this, and I will open Postman because this is ASP.NET, so I need some form of invocation. So it will succeeded. This thing is running. And now let's, and that was the wrong program I started. That's also very nice. Super sorry for that. So, good. I have here my Postman, which maybe or maybe not decides to render some content. And I will invoke exactly that route. It does something. That's very nice. So this is where it runs. This is the deadlock endpoint. So let's go send the request and jump into the controller, and let's see what happens here once the debug symbols are loaded. And then let's go through all the stuff. So caching assembly is also good. It's a very important job. Take your time.
There's a question from the audience if you could make the font a bit larger.
Oh, sorry. Yes, of course. Sorry. Is it a bit better now? All right, let's like that. I hope this is now visible.
Looks good to me. Yeah.
Good. Okay, so we see here now we are in the controller call. We are on the right line, and we go to the async task, which we will await synchronously. As I said before, we will go into the function. Okay, we have the welcome, and now we go to await, and we return everything after that as a continuation task. So we jump back to the caller, and now we wait, and now we wait. And if I would be very, very lazy, we would wait until 8 o'clock and nothing will happen. But I will not do this. But as you can see, I will not receive any response. There is nothing coming. So let's do the same thing in a normal console application. So let's go here, and here's really the same happening. I will just make it bigger. So hopefully now it's visible. We have the same principle. Or we have a async work, which we will enter. We have the task delay as in the ASP.NET controller call. We will wait. Oh, thank you. And then we will run a console write line afterwards, which we never could not respond. Thank you. Which we will never, or we have never reached in the ASP.NET controller. So let's try it here in the console application. What happens here? So we are here. That's what we saw. We go into it. We go until the await task delay. We go out, we wait for it, and oh, we reach this. Isn't that funny? So it works somehow differently. Just because I switched to a console application, it works. And it's magic, isn't it? Not really. It's not magic at all. So let's talk a bit. Why does it work? What is a synchronization context and what is a task scheduler? Because those concepts, these are responsible for the behavior we saw. By the way, if you have any questions, it would be nice if you just unmute yourself and just talk, because I have on my second monitor something else open. So sometimes I'm not always looking into the chat. That's would be very nice if you just, shout.
I think Jose and I will keep track and give you a hint when there's something.
That's very nice. Thank you very much. That's very much appreciated. Okay, let's come first to this task scheduler. What does a task scheduler do? It's pretty simple. The task scheduler is literally meant for what his name is, supposed to do. It's responsible for executing scheduled tasks. And .NET has mainly two schedulers, or let's say the .NET framework. If you have something like Mono, this can be a bit different. But .NET itself has two main schedulers. This is the thread pool task scheduler and the synchronization context task scheduler. And the default is the thread task scheduler, thread pool, and ASP.NET uses the later one. And you see here, there has to be a difference because one makes you a deadlock and the other one doesn't. So let's look, what is a synchronization context? The synchronization context is a mechanism for communicating between tasks. It's pretty simple. This is exactly an abstraction of how you would communicate. And what it is in .NET is the representation of your current environment where your code is running in. So basically, if you want to go asynchronously and you want to await something, it makes a snapshot of that environment. And it is saved on this specific task object you are awaiting, or you are also returning to your caller. And the whole thing is it just provides a way to queue a unit of work to a context. So why do we need this? We saw somehow the console application doesn't need some things like a synchronization context. It just has a thread pool and it spawns literally new threads, but ASP.NET doesn't do it. So why do we need it? And I guess a lot of you have experience with Windows Forms or WPF, where you are only allowed to modify or destroy UI element from the thread from which it was created. Otherwise, you will get an exception. But if you want to offload some work and you want to come back, you want to be able to update such UI elements. So you don't want to be on a different thread or better context, because then you wouldn't be allowed to update or delete stuff on the UI. So the synchronization context allows you exactly that. You can offload some work in the background, and when you come back, so after the await, you're still allowed to update or render UI elements. That answers at least the question for WPF and Windows Forms, but how does it work in ASP.NET? It's mainly used for the HTTP context current, some culture information, and identity information. So how can I prevent the whole mess with a deadlock? And this is where ConfigureAwait comes into play. And it does not that much. Basically, what I told is when you go into this await, you capture the current context. So when you want to come back after you finished, you running on the same context again. And if you ever watched or looked how the first parameter on ConfigureAwait is called, it's just called continue on captured context. And when you set it to false, you say basically, I don't mind whoever continues the execution. So it doesn't matter if it's another thread, another context, you don't care. The truth is you don't have a context at all. Your context will be null on the task object, even if you're on the same thread. The context is just not there. When do you use it? Normally you use it for libraries because you don't know necessarily where your code will run. So you can't make this assumption that you never can run into a deadlock situation. And also you get a small performance improvement because you miss out the synchronization. So you don't have to have this mechanism which synchronizes your contexts from the task object. You miss this out, so you gain some time. It's not much. We will see this later. So that sounds awesome. So we should use it everywhere then all. That seems like a very good idea to me. So earlier we saw that the synchronization context of ASP.NET is responsible, for example, for the HTTP context current or some culture information. And if you have no context, those information, of course, are not synchronized. So what you can see here is after you used ConfigureAwait on line 17, your HTTP context current will be null. It's not there, it's just null. So if you rely on this information after you awaited something, you're out of luck. You can't use it in that way anymore. You have to find another mechanism to save it before or synchronize it the other ways. So what is a proper solution to the whole point? Yes, it would be async await everywhere and everything to the whole chain. And the first question is, why is this different in the first place? What does .NET do that we don't run, for example, into a deadlock? Well, and this is also pretty easy because if the entire call stack is asynchronous, there is no problem because when you reach your await, your original thread or context is released. So when you remember the situation from the beginning, this task delay thingy, he wants to return to something which is 100% of the time blocked because it wasn't released, it was just blocked. But you are not blocked here. You're releasing your context, you're freeing it. So you just can run afterwards. And also you have another advantage. Oh, sorry, there was one too far. Your HTTP context afterwards will be available. Also, if you have a UI framework like WPF, also those stuff which gets synchronized via the synchronization context stays there. Of course, would you add a ConfigureAwait here on this line? Of course, it would be null afterwards and not be set. Just the nature of ConfigureAwait itself. Let's talk about ASP.NET Core, because this is the way to go and not this old crappy ASP.NET 4 point something, which barely someone uses. How does it work in ASP.NET Core? And here it's pretty simple. ASP.NET Core has no synchronization context. You will not run in this issue at all. And the best thing is everything in ASP.NET is mainly managed through DI. So such things as HTTP context, you do via the container or other things. It's not like a static property you have to call and has to be synchronized over different threads. Therefore, you have not this problem with ASP.NET Core. Or the same holds true for any console application with .NET Core, for example. Let's have a very brief outlook to the state machine. A state machine itself is quite complicated. So I will boil it down to some aspects it uses and what it does, and will also leave out a lot of optimization. I will tell you later what optimization there has to come. So on the left side, you have a normal, let's say, class, and you have a function get stock prices async, which has some sanitation checks. Afterwards, it calls the private function here and does something afterwards. So this is the part we are looking into. And if you see this here, get stock price async, on the right side, you have the same name underscore state machine. What does it mean? Well, every async function you create in your code will, after the compilation, will be a class. So 2 async functions would also mean 2 async classes. Just that you know that. I can show this later to you. How does it exactly work? So what is the basic principle once we split this? So we know, okay, this will be a class. Fair enough. Let's split the original method into pieces at the await boundary. So we have this is our boundary. We have await. So we have a part before, we have the await part, and we have stuff under it. And every awaited task now becomes a field on the state machine. And I can show you this. So, and the start method subscribes itself to a continuation. So what does it mean? We see here this stuff. We have the if string is now empty. This is from here. We have the task. This is what I mean with every awaited task now becomes a field. I can show you also this later up here. This becomes really a field. And afterwards, we basically have some state machine. So, I mean, we call it state machine. So there has to be some transition. And the transition is here from initial state to step 1. This is down here. And after we did this, we return ourselves as a continuation task. So let's continue. What happens? Well, once your await is done, you get called again. You can see this, I go one spec, you can see this here. You will be called afterwards. You call yourself, but with an updated state. So you're not start state anymore, which was defined here, so initial state. But now you are on step 1. So we also do step 1. What you see here is some also sanitation. For example, did you get canceled? Do you have some exception? And only if you're not get canceled or you don't have an exception, you continue the rest of the code. For example, here you see try get value and some other stuff. Outward result, exactly. This is this one here on the line 9 on my left code snippet. And once you're done, you set the result. This is also done here. This is very briefly how it works. And the main components you have here is you have the task completion source, you have the continuation, and you have some sanitation around with setting the result. You can see that the task itself, which is passed outside, comes from the, you can see it again, task completion source. So this is doing all the magic for you. And if you want to see a real example, There's a nice site it's called sharplab.io. I just show it here, sharplab.io, if you want to know it. What it basically does is you have multiple options. You can, for example, lower your code in debug and release mode. And you can also say, okay, I want to have different C# versions. So you can see what does the compiler do at the end. And basically, I have the same example here where I just have return async. And yeah, you can just play around with it, but you will see the same components I showed you. Oh, sorry.
Yeah.
Someone was not muted. So you can see the same thing as I told before. You have the do async state machine, which is a class, and you have the return async state machine, which is a class. And you have the task awaiter, you have the async task method builder, which is basically your task completion source. And you have here this await unsafe uncompleted is basically the continuation where you have the state machine. One small thing I can also show you can toggle between debug and release. And what you see here is instead of a class, you have a struct. It's just performance improvements. If you want to know more, just head over to sharplab.io. You can just pass in any code and you can see what does the compiler do for you? What happens at the end? It's a nice tool if you want to understand some aspects of the language better. Also, for example, IEnumerable yield return. How is the state machine there concentrated? This you can also basically look it up here. So one thing I always hear when we talk about state machine is performance. Performance is crucial. Performance is so important. And having the state machine and async await is so expensive. Can't we not just omit it? And I have a small test, or I contemplated a small test, which is pretty simple. Let's zoom in here. You have here just an example.
There is a question. I just saw it. I don't know because I was away for a couple of minutes from Stephen Landgraf. I don't know if that was already responded or asked.
Ah, sorry. Yeah. So yeah, I saw it right now. I opened. Sorry for the late answer.
I can read it for you, or you can.
I have it open right now.
Okay.
Yeah. So the question is, if ASP.NET Core has no synchronization context, how is HTTP context synchronized? You don't need. I mean, you normally get your HTTP context not as a member of the controller. It doesn't exist anymore. You will get it via DI. So there is no need anymore for that. Basically, there is nothing to synchronize because whatever you want to have, in special terms, the HTTP context lives somewhere else now, to make it very simple in simple terms. That's why there is no synchronization context anymore. And this is one of the big joys I have also with ASP.NET Core, that everything is so DI driven. That makes it really easy. I hope this answers your question. If not, I now have the chat window open. I'm sorry for the delay. Okay, I will show you short this benchmark. This benchmark is pretty simple. It's based on benchmark.net. I guess a lot of you people know what it is. It's a super fantastic library for benchmarking. It's super easy to write some benchmarks. You annotate 2 or 3 things and you can run it, and then it's easy. What did we do here? Okay, we have a simple task, yes. So we have here just a string which we return from a task object. So we keep it pretty simple in terms of what our task really does. Basically nothing, returning a string. And we have 2 versions of that. Once we await this whole thing, and once we omit the await. And the goal of this whole thing is to know how much time or memory does this await or one await really cost? Is it worth omitting? Is it worth having it or not? And I checked this with multiple runtimes. So you have the old .NET Framework 4.7, you have the normal one, the current one, 5, and the upcoming .NET 6. Right now I have installed the preview 5. So this is really the latest version. And this is just run it and you get some information. So this is how it looks like. Make it big. Can I screw? Oh, yeah, I can't. That's so perfect. Okay, so you see
the font
the job
bigger before anybody else asks.
So this is max width. Okay. I hope it's visible.
I mean, if you, yeah, that's it. Perfect.
Perfect. Okay, so just to explain what happens here, you have the method. This is get string without the async and with async, and then you have these 3 configuration I gave. So once .NET 5, .NET 6 and old .NET framework. And what do you see here? Okay, the most important thing is always compare the odd line with the even line. What you can see here is basically you have a difference of 30 nanoseconds. And in the old framework, it was around 80 nanoseconds. And this is not relative.
Once we are hearing, at least I am, every now and then a bit more glitches from your audio, from your microphone. So I don't know if it is maybe losing power or it's not fully charged.
Just fully charged. I'm sorry. I can just be louder. Maybe it's the...
No. It's about maybe the connection from the headset to the computer or your internet connection.
Okay. If it's getting bad again, let me know. I will switch otherwise my hotspot.
Yep.
Okay. So again, I wanted to show here that if you omit the await, you basically save 30 nanoseconds and some bytes. You see this here in the most right column. Allocated means how much memory did our benchmark use, or the objects under our benchmark. And these are absolute values. So what does it mean? Well, it's not really that expensive, but as always, you should measure your stuff. But I just want to give you an impression that it doesn't really cost that much time to have an await. And why is an await important? I will show you in a few seconds. So, Jose, maybe your connection, at the beginning, you were a bit also robotic. Maybe your connection wasn't the best, but it's just an assumption. Okay, does anyone have any questions to the benchmark? At the end, I have everything in the Git repository. So if you want, you can just check it out. You can run the stuff on your own. You can modify it on your own. All the examples I will show, plus some others, will be on GitHub. I will put them into the slides and upload the slides. And when you want to know anything about it, just clone it and play a bit around. But quintessence is, it's not that expensive and it's not that memory intensive. But as always, depends on the context. If you run the stuff in a loop millions of times, of course, this adds up. Good. Let's go back. We were here. Now, let's come to the pitfalls and some general tips. I mean, this is what was all about. And in the introduction, I showed you basically this example. What is the difference between await something directly and having a task which you await or which you get returned and then you await it? Maybe through the course of the last 40 minutes or the 30 minutes, you have now maybe an impression of what's the difference, but let's see. I showed you this snippet. It was basically that. And if you want, I give you now a minute of time. You can go to the poll, to the straw poll, and can check once again. If you, or you can just vote whatever you want, if you feel there is a difference. I will come back like in 20 seconds and we look for the results. Thank you for posting the link again. Good.
Mac is bigger than you, Stephen. That Mac is bigger than you.
So now 18 votes. And we can update. There's another one. No, 80 votes. Okay. So we have basically one group saying snippet A runs 1 second and the snippet B, I can go back. This is snippet A is the await afterwards. And snippet B is I will await everything directly. We have more votes. 8 votes for that, 5 votes for the other way around. So snippet A runs 5 seconds and snippet B runs 1 second. And we also have 5 votes for both run 5 seconds and 3 votes for both run 1 second. So is there something else? One last update, good. I would say let's go to the IDE and just find out. That would be the easiest way. So, no diff, thank you. I have this here. Okay, I can show it basically here at this small example to give you an impression how long will it take. So we have here the await directly, which runs in a thread. And the other thing is you have the task and it does something else. And if you run this, you will see something. Wait, we make it more obvious. Let's say this thing waits 5 seconds. So now we go in. Yeah, so we have the write line and then we wait and we wait 5 seconds. I mean, this is what we expect, don't we? And then afterwards, we go to the console write line. What does it mean? Well, yeah, 5 seconds passed and we will finish this thing completely. So what is the difference now? This is a bit what I explained at the beginning. If you only return a task, the whole state machine kicked in. So you have the first thing is basically you call everything before the await boundary. So we are here. Now we await something. And when we await it, we continue everything which comes afterwards as a continuation task and go back to the caller. So we go back to the caller and we can do some stuff and then we await and we are done. And that was pretty fast because in the background, it just ran. And maybe this gives you an impression now what is the right answer, because the right answer to the whole thing, and I come back to now, is snippet A runs 1 second and snippet B runs 5 seconds. Why is it so? I can also explain it here. Every time when you have this task, which basically does almost thing, you just go down and they are all, you could start it in parallel, but this would be the wrong word. I hope you get the idea. Once you go from line 1 to line 2, this thing is starting its delay. And furthermore, if you go down further, everyone is started, and then you wait for the first one. And if the first one is done, yeah, basically 98% of the second one, 97% of the third one, and so on is also done. So once you reach E here, this is basically only 1 second passed. But here it's different. You wait for the full load of this 1 second before you go the next line down. So when you really want to do independent work, what you normally do is this approach. You start something and do some, for example, independent work in the meantime, like in this code sample, you do the independent work, which is here, of course, only some console write line. And then you await it when you literally need, for example, the result, or you need that the operation is finished. I hope this is so far relatively clear. So does it behave differently when executed in release mode? No, that's the same. The only thing is you have a structured set of the class, but the state machine as a concept doesn't change. Only how different things are treated are changed. But this is mainly due to performance. But this awaiting, I mean, I can just, release. I have debug symbols, of course. You could argue now, okay, your debug symbols, they will do something. But yeah, no, they will not. So let's do here, 5 seconds delay. So we go in, we go to the write line, we go to the delay, and we wait. So we will not jump out of the function and do something here. We will land after 5 seconds here. So let's go further. This function is done. And here is the independent stuff. We go in, we do something, we await. And now we see, we go out, and now I await a task. This is basically only like 2 seconds left. Done. This wasn't 5 seconds. So release or debug doesn't change the behavior of the state machine, mainly a bit its implementation details, how things are treated, mainly due to performance reasons. Is it the same if only have 2 threads cores available? Yes, because all these things don't necessarily have threads involved at all. And okay, this is a bit unfair in this. I mean, workload is different. That's true. When you have workload, it's different. You can run into different situations when you have workload. And this is mainly because of, I guess you speak a bit about task run, which works a bit different than IO based operations. So I will also show you this later. There's a difference between IO based operations and CPU based operations. And mainly, or the main use of async await is IO based. What does it mean, IO based? Well, your CPU is not really doing anything. Something else, like your network card is doing something, or your database doing something, or your IO is doing something, but your CPU is kind of idling in this mode. And task run especially is different in this regard, and I can show you later why. And also task delay can behave differently, because internally task delay will always start a new thread. So for example, I can show you this here. I hope this is easy to see. Initially, I told you there isn't always a new thread involved. And this is mainly lots of the times it's true. Here in this case, for example, not. And this is literally because of task delay. So if you do experiments and you want to check, is this multi-threaded or not, you have to check your implementation of whatever you do. Also, task.run will create a new thread. So let's go back here. We were here. Oh, there is another vote. Oh, 9 votes. But majority, or 40.9% of you had the right guess. Let's talk about exceptions. And let's talk about exceptions in the context of, I don't care if I await something or not. And this was, I have too much here. There's my exception block. Good. Let's go to exceptions. What do I have here? It's pretty easy. I have one with await and one without await. It's a bit like we saw earlier with the thread pools. Yeah, they are actually rented from the thread pool and they are limited, and there can't be an infinite amount of threads concurrently. It doesn't work. So this is the example we had before. You have ones with await and ones without await. And both functions with or without await do call a function which is asynchronously. I just use task yield, so it's definitely asynchronously. And oh, sorry, yes, the code text is small. I'm sorry. So again, we have 2 functions, and those 2 functions call one time the throw exception async with await and one time without await. And it's just really throw new exception. So here are 3 calls involved. We have, it's not necessary here, but also good that I put it here. We have the main function. We have the do work without async and the do work with async, wait, sorry. And we have the throw exception. So in a stack trace, you would normally see, if you have everything synchronously, 3 functions: main, then the intermediate function, and the throw exception function. And of course, this will work, for example, if we see it with await. Let's just run it, and let's look here on the output. I will make it a bit bigger in a second when the window switches to the output. So, and what we see here is what was clear. Also, we have to throw exception, we have to do work await async, and we have to program. All those 3 functions in the chain are visible in the stack trace. What happens if I switch this? So let's call this. And what is different now? And you see, there's a change. We have throw exception async and main. So one function less, and the function less is exactly this one, the one where we don't await stuff. So when you don't await a function, you will not see it in your stack trace. This is one main reason I don't like to not await stuff, because Yeah, it's not that expensive. And if it's not the hot path or a hot path where you know it is invoked very, very often, just put the await there. It makes your life easier. You know, you save maybe 40 nanoseconds, but if you have to find them through logs some exception and who calls you, I don't know, you will take more time than 40 nanoseconds. That's why I'm a bit biased to just put it there. Okay. Not properly awaited task is another problem. And the first one is this. Let's look at this small code. So you have a list and you have a repository which has an asynchronous function. You call for each of these lists, for example, IDs, it's just for demonstration purposes. What is the problem? That we do not await here, or that's tricky, that's not good. So let's do this. Looks better, doesn't it? Async, await, now everything is fine, isn't it? Works as we expect. And the answer is no, it does not. And why doesn't it do what you expect it would do? Because for each on list only accepts an action. An action itself is not awaitable. You can only await tasks and value tasks. So this cannot be awaited. This would mean from a calling's perspective, this is the same as async void, and you can't await async void. And the same applies to most of the link queries, for example, select or where. So if you have asynchronous stuff there, you cannot just make async await and it works. No, you basically have to select the tasks and have to await them at the end, one by one. This is what you would do. Okay, another one without awaiting. When we are at the topic, let's have a look at this nice code. You have some controller call or whatever. You have an HTTP client which gets you a string from a given URL. I know you wouldn't necessarily do this in a productive code. Please don't create HTTP clients on a function call. You only have them once. I know, it's just for demonstration purposes. What is the problem here? Yeah, your download will most likely be aborted because the client exactly gets this post. And this is what we exactly also saw earlier. You run until the first await inside this get string async, and then the rest will get passed back at you as a continuation task. And at this point, you're just at the end of your using block, which means your client gets this post and most likely everything gets aborted. So you have to be careful if you await or if you omit such awaits, because you think you save some, I don't know, allocation space, you save a few nanoseconds. It can be very, very dangerous depending on the circumstances you do. And the proper solution here is just put this await there. That's the easiest one. Just have this await. Good. Okay, repeats. Okay, another one. Await and for each is also a common misconception how it works. Let's have a look at this code. You have a for each with, for example, here an array of 3 elements, and each time you wait 2 seconds. Well, what is the whole runtime of that thing? And this is a bit what we saw also earlier, the first example where we made this drop pull. I guess I have, yeah, not that 5 here. So if I run this whole thing, this will take 6 seconds. Every time this thing will get called and we await here, we do not go to the next iteration. To the next iteration. We will wait here. We have to wait until this thing is over, and then we do the next one, which means this whole thing will take 6 seconds. And I can also show you that. You don't have to trust my word. We can just look on it. So doing 1, you see, and then 2 seconds later, and then another 2 seconds later, and now we're done. So how can we make it work so everything here is, let's say, really asynchronous, and we do not await everything one by one? And the easy thing is just use tasks. You can have a list of tasks, and then you call await task when all. This example I showed you earlier, that would mean basically the runtime would be 2 seconds. The only thing you have to be aware, task when all will not give you any guarantee about the order of your execution. You do not know if it's 1, 2, or 3, which is called right now. It could be also 3, 1, 2, 2, 1, 3, 3, 2, 1. It doesn't give you a guarantee. So if you need order, this would be not your approach. Let's go on. Some other pitfalls. Async void, the favorite ones, don't use it. There's only one exception, and this is top-level asynchronous event handler. They're the only one, and they're really, really dangerous. And I also have a small example. You can just check out the GitHub repository later. And oh, wait, it's not allowed here. Wait, yeah, of course not. So you have here throw exception async, and you can never catch that thing. This thing will not be catched, and I can pretty easily also show that in the sense of I've just run it. And here you see, if we can catch this exception, we will see some console write line, including exception, and then we throw it further to the .NET environment or runtime. And if it doesn't get catched, we see, was there something? And this is also basically exactly what we see. So let's call this thing. I will make it bigger in a second. Yeah, of course. So, and we can see here, was there something? And that you can see unhandled exception, this comes directly from the .NET environment. This is not something I can catch. This is what basically .NET environment does for me, or the runtime does for me. There are ways to catch such environment, to catch such exceptions, sorry. But it outweighs any pitfalls you have. There's no way this can be good because you can catch something with app domain unhandled event exception. Doesn't mean you should use it. This is fire and forget, and there you have other ways to do it. At least only use it for top-level asynchronous event handler. Also, these are horrible to test because you don't know when they're actually done. So your tests can get either very flaky or you build some horrible tests, and both you don't want. Coming to some general tips, and the whole journey I wanted to talk about is asynchronous and parallel programming is not the same. There's not always a thread involved. There's sometimes only one thread involved because it uses callbacks. And if you want to really, really nitpick, you have threads, but on a different level. It's on the kernel level because someone has to handle the communication and the interrupts. And if you want to know more about that, you can have a look at direct memory access. This is how your network card or your SSD or whatsoever, and yeah, how it does that in cooperation with your operating system. They inform you directly in the memory that something is done, that the result is done of the operation, and not, for example, your thread. It's just idling around, or it's just freed. Good. Task.run, we had it a few minutes before. It's meant for CPU-bound operations, and there's also this old method, task factories.new. It's obsolete. Microsoft says you should use task.run. And you have to be a bit cautious because of two things. First, it's really meant for CPU-intensive tasks, not IO-bound. So some things in the async await can behave differently because you can, for example, run out of threads, or threads are really doing something. So you can run into deadlocks again because something is running on thread 1 while thread 2 is waiting for it, and vice versa. And you should be cautious when you use it in ASP.NET or ASP.NET Core because it decreases your scalability. And this is mainly due to the fact that each request in ASP.NET Core is one thread. And task.run will remove one thread from your thread pool. So at some point, you're running out of threads. They are not infinite. And they depend on various factors, but mainly is your virtual address space, how much threads you can have in parallel. Plus, even if you can have unlimited ones, your CPU isn't unlimited. So you have to have a lot of context switches of those threads. And this is also, yeah, expensive. And you will feel it. So if you have ASP.NET Core, I'm not sure how useful this is to have parallel things massively with task.run. There are better approaches. Exactly. So another one, try not to mix synchronous code and asynchronous code and vice versa. What do I mean with that? For example, you have EF core. EF core gives you save changes and save changes async. If you have an asynchronous function, use the asynchronous version of save changes. If you have a synchronous one, use the synchronous one. That's if you can do that. There are some times you can't avoid that. And for that, I will come later here. You can
Steven,
see.
there is a code rule, Sonar in this case, that usually tells you to wrap a call, for example, HTTP call in ASP.NET Core in a non-asynchronous call that checks the parameters and then issues a call which is really asynchronous. What do you think about this? Does it ring a bell? You think it's good? Or
can you explain the situation again? You have ASP.NET Core call, a controller call, for example.
Yeah, for example, there is a code rule that I believe comes from a static set of code rules that tells that you should put a call which is not asynchronous. For example, like a REST endpoint in a controller, and you should verify all the parameters, that everything is compliant, that the parameters are properly set up, and then issue with that the call to the asynchronous endpoint, to the execution. I don't know if you have seen that rule.
No.
I remember it. I should search for it now, but I can come with it later.
Oh, yeah, that would be good. If you have for example, a link to something, that would be very nice.
I don't have it yet, but I will look for it. Let's see if I can give it to you before the end of the session.
Okay, we have another question. How do you make an async function which calls a sync function from a library which gets no async version? Wait, I have to understand. So we have a library. We are using the library, as I can understand. I mean, you can just call sync function. This is no problem. It's not like you cannot do this. This is the debug write line, the console write line are all synchronous. It's just more of, given the option you have both, you should basically stick to the pattern. So if you have a synchronous function in your repository is completely synchronous, then stick to save changes. And if your repository is following asynchronous patterns, then use also the asynchronous version of DB context save changes async. It was more about task run.
Yeah, so basically you want to build an async function that uses a synchronous function inside because that's the only one available.
Yes.
So what do? You're not using task run? What is another method?
No, you can use task run if you want to make it asynchronously. If this is your only way, you could also just say task from result, for example. And then just, if your function returns something, you can just task from result. This would be the easiest way. Task.run is really meant for CPU tasks or CPU intensive tasks, and not necessarily just to offload something.
I see. Thank you.
Yeah, exactly. Schweitzer also wrote, no need to, yeah, sorry. Yes, Sonar source.
Yep. I'm curious, what do you think of this one?
Should be read. Non-compliant solution. Skip lines. Okay, so what they do here, but I mean, for example, here I'm just not a big fan of that.
Yeah, me either, but sometimes
I know this. Yeah, I don't know what's the biggest gain out of it. I mean, because of, I know it's all. Wait, sorry, it's very small for the audience. I tried to make it a bit bigger, but I can't.
Yes.
So the basic idea is, you say non-compliant code example, that if you have an asynchronous function, you should split it in a synchronous part and the async part. So that, for example, you can see it here. You have the skip lines async where you make the sanitation checks at the beginning, and then you just return the task. And here's the real asynchronous thing happening. For me now, the problem is, let's assume your reader is null or lines to skip is smaller than 0. It's just really hard then to find anything if you await this or if you pass it through, or just imagine here something happens. It's just your stack trace looks different and omits some functions. I mean, it's personal preference. I would argue against personally. That's my personal opinion. I know that, yeah, Sonar analyzers are pretty nice in general, but also on our projects, some of the rules we disable because we don't think they bring you much value. They can bring you value, of course, I agree to that. But for me, it outweighs the dangers you have. You have more danger with that. And you make your life harder without any reason. So for me, I would omit this rule. Does it answer your question, Jose?
Yes, it does. I believe this is followed as well to ensure that theoretically, if there is any parameter wrongly stated, it returns really right away.
Mm-hmm. We had at the beginning a bit, ConfigureAwait is always a good decision in libraries. Of course, what I also told exception is you need something from the context itself. For example, you modify some UI elements or an ASP.NET, you need the HTTP context current. Then, of course, you can't use it right away. But this is, yeah, most of the cases you can do it. Also, how do you call an asynchronous function from a synchronous function? And Stefan also wrote something in the chat. And Microsoft, I will not go through in detail here. I just want to check. There is a whole page, and I will just scroll a bit so that you have an impression what you can do. You know? So it depends a bit on your situation you want to achieve. There are pros and cons. I would suggest read this article. It's quite informative. And their best decision or their best advice they give is try to use asynchronous function in the whole chain. That would be the best. Another thing important for me is use cancellation tokens. They are there for a reason. They have their existence reason, and they are good. They are nice, especially with ASP.NET. Use them. They're good. They're easy to learn. You just pass them through. You don't have to take care of them much on your own. You can just pass them through. It's nice. To sum all this up, use await by default. This is just my personal opinion. If you really want to omit it, you have to justify it. That, yeah. And try to be asynchronous in the whole way, and the whole chain, I'm sorry. And when it comes to performance, don't rely on feelings. Measure first and then act appropriate. It's really difficult just based on feelings to argue, and based on feelings you just implement stuff. That's rarely good. And also you don't know what is your outcome. Did you really achieve now some milliseconds more? Did you really save some precious byte more? You don't know. So measure both first and after you act, so you know if your actions were useful or not. Let's come to the last part, ValueTask. Let's make a small, brief introduction to that. It was introduced with .NET Core 2.0. And the simplified version of that thing looks a bit like that. You have a read-only struct, which consists either out of the task or just the result itself. So what does it bring? Yeah, you can either return it from an asynchronous function, but you can also call it from a synchronous one. And the main advantage is if you call it from the synchronous path, there's no task object allocated. It is pretty nice. And this saves you A, some time, and B, a bit of memory. This is the main use for that thing. And a classic use case, for example, is let's assume you have a weather service which gets you weather, but it also has a cache, for example. And this cache is in memory and completely returns the synchronous call. So there's no await, there is no offloading. You can directly return your value from your cache. But there's also, if the hit in your cache doesn't work, you have a repository which gets you the weather for a given city. So this is what I explained earlier. You have both ways. You're not always going synchronous, but you're also not going always asynchronously. This is a typical use case where you could use it. Is there anything else one should be aware of regarding cancellation tokens besides freeing resources if the task is canceled? Yeah, what you can be aware of is there's multiple ways how to cancel a task. There are sometimes only properties involved. There is sometimes an exception involved. And at the end, it's the maintainer of the library who decides what happens if the cancellation token is canceled. This is sometimes a bit annoying. Normally, or at least in .NET, it's an exception. So there's cancellation token dot throw if canceled. It throws an exception, and you can handle it however you want. And it's very good. Freeing is always a nice idea. Yeah. So this is one thing you have to be aware. What happens if the task gets canceled? Is it just a property set, or is it an exception? And if so, which exception gets thrown? So exactly, coming back to the value task, whether repository is async and the cache is completely synchronous. Big no-nos, what not to do. And this is literally from the value task MSDN side. So this is nothing I made up. This is even what Microsoft recommend. You should not await multiple instances of this thing or calling as-task multiple times. You should not call result or get await to get result when the operation hasn't yet completed, or even if it's completed, do not call result or get await or result multiple times. Also, do not mix those techniques. So do not await and afterwards call as tasks. If you do this, the result will be undefined. So should you take it is the big question. Short answer is no, you shouldn't. It's made for performance reasons. So long answer, it depends. If you have a hot path, you really know it's your hot path, it's very critical, and every small millisecond, every small allocation matters, then you can do this. But be aware, this is a micro optimization. Maybe you have other ways to do first. So for example, your SQL query is slow whatsoever. So this is really on a very, very technical level where you go. And this can be very, very dangerous, especially if you have a library where you don't know how it is getting used every time. So also do benchmarks, identify the problems, and then act accordingly. Don't use it just because it was introduced and it sounds fancy. Good. This is, if you have, I will, as I said, upload the slides. If you want to have those examples, I put you a link. If you want to know about or more about synchronization contexts, then I provide you also multiple links, also the state machine, well written, if you want to know more how do the details work. And here's also value task, some information directly from MSDN. Also a small entry about why are there no threads and how does it still achieve responsiveness. If you have any questions, let me know. I hope I could give you a small update how async await works, and you could take something from the small presentation with you, or you even saw some patterns or anti-patterns on your own daily base and could now correct this a bit. I would be done so far. If you have any questions, let me know. It was a pleasure, and I wish you a nice evening and yeah, a great rest of the day. Thank you.
Thank you, Stephen. So now's the time, gentlemen, to make questions. I have one for you, Stephen.
Yeah, sure.
So will you publish on our meetup page the link to the presentation so everybody can get it?
Yes, I will update. Sure.
Perfect.
Thank you.
Now, well, come on. More questions. We will wait like 1 or 2 minutes. And if there are no questions, then I will close the stream. And then we will invite everybody to unmute and to put the video stream on once we go offline. But come on, more questions. Yeah, I'm curious. It was really, really interesting, at least from my point of view.
Or someone wants to see again some of the code details. I guess I went through everything, but we can also go again through if there's some need for that. Otherwise, as I said, I will post them on GitHub. Here's the link, and you can check it out on your own and can just play a bit around. Mm-hmm.
Cool. So more questions. Come on. 1, 2, 3. Time is running up. You will not have Steven all days. Just now. Use him. All right. So there are no questions, and I will stop the live stream.
Oh, wait. There's one question.
Oh.
Would be other than small performance reasons for goal task without await. Let's assume. Let's go to the code. Okay. So the question is, let's assume you have not this await. Where is it useful? Well, sometimes you have just, let's say, functions which don't do anything. They just really have one line. Let's say we have this private task do something. Async, because why not? And we have private async task do the real work. Async. Then maybe I should and here we have, for example, I don't know, await task yield, and we do some work here. Yeah, so I hope you can see the screen. Do some work here. And I mean, if you do this, yeah, you really don't have anything else to do. You don't have any sanitation, you don't have any checks, you don't do anything with it. I guess it's quite fine to do so. This can happen from time to time if you have a repository which is relying on something or whatsoever. So I see there are scenarios where this can happen, to stick, for example, to a pattern or whatsoever. This is quite fine because you don't gain any information, because this does nothing. There's no exception coming from, there's no side effect from this function. So here I would say it's totally fine to completely omit the await instead of this. You just return the task. You can just return it. I guess this is fine. This is one of the small examples where I see fit for omitting the await. Other than, of course, performance, you really identified a hot path in a very, where you invoke something multiple million times or so, then it makes also sense maybe to omit the await. But in general, I would say really justify that you want to omit it instead the other way around. At least then you have some safeguard for yourself to say, okay, does it really make sense to omit it here? I do some checks before, and those checks can throw an exception, and I don't know then from which function this exception came from, because the stack trace omits that. Any other questions? Oh, there are new messages. I have to click.
There was one, but I think Michael is responding.
That could.
Michael, you can put your audio on if you want.
Yeah, sorry for my audio glitches. That could very well be this is my hands. I'm very sorry for those unconscious patterns.
Tie your hands behind your back next time.
All right. So
everybody back.
I think there are no more questions. Anybody? We're missing any question? 1 more minute. Oh yeah, Stefan just made an interesting question.
Do you recommend Microsoft Vision? Yes, I like that. At least it gives you a warning. And if you have your project settings, if you have your project settings, for example, treat warning as errors, this will force you to have such implementation. This is also force you to actively, you have to actively decide, do you want to omit it? Because then you have to bring a reason as in form of, for example, of an attribute to call or to say to the analyzer, hey, it's fine that we omit that. So for me, such analyzers are nice. I like them in general. There are, of course, also exceptions, but yeah, I like them. I also use what was posted earlier, this one. This is called Sonar analyzers. from Sonos Source. They have a very, 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 very big rule set, and sometimes it's a bit annoying to go through, but they are also good. So I guess they even have the same one also with the async await thing, that you should await the stuff. So yeah. Here, for example, async method should not return void. Such things. You should use ConfigureAwait. It even prohibits you from using ValueTask wrong. Oh, here you can see the same reasons. If I go a bit further down, can I go to the right? Okay, the site doesn't really allow scrolling with my mouse wheel. But yeah, they're good. The compiler description. What do you mean with compiler description?
That website that you showed before.
Sorry, yeah, exactly. Yeah, I have the link in the presentation. It's called sharplab.io. Let's go here. By the way, if you're interested in that, the slides are made with Reveal.js. So here on the slide, you have this real life example, and this will lead you exactly to that site. So Sharp, I will post it here. This is more visible.
Yeah, SharpLab at the Roslyn playground from the Roslyn team. So you always can. The cool thing is you can switch between their branches. So if you want to, for instance, try out the new features, you can already try them out.
Cool.
Good.
So they are going to be posted together with the presentation.
Mm-hmm.
So cool. So more questions? No. 10 seconds. 5. So that's it for the session. Now we will have some